Alright, this is question number 2 from the free response. It gives us a function f of x plus 3 times quantity x minus 2 raised to the 2/3, as well as its derivative and its second derivative. And it also tells us that f of 0 is approximately 4.8. So the first one asks us for the domain of the function. So we come up here and we want to know when this is undefined. Well, there's no division, so we're never going to divide by 0. And then we have to look at this exponent. But since the denominator is an odd number, it's 3, that means that this is an odd root, and odd roots have domains of all real numbers. It's the even roots that we're looking for. So the domain of this function is going to be all real numbers. Next, it asks us for when it has vertical asymptotes. So vertical asymptotes is when we divide by 0 in the original function. Since there's no division here, we're going to have no vertical asymptotes. And then also, it asks for horizontal asymptotes. So remember, horizontal asymptotes, we look the limit as x goes to negative and positive infinity. But what we have here is just a polynomial, because we're not dividing by anything. So this is going to go to both negative and positive infinity on both endpoints. Doesn't matter what it is. So we're going to have no horizontal asymptotes as well. Alright, it also asks us for the y-intercept. So remember, the y-intercept is when x equals 0. So we just have to plug 0 into the original f. But actually they told us what f of 0 was. It's approximately 4.8. So our y-intercept is 0, 4.8. And they also want to know the x-intercepts. So that's what makes the original function equal to 0. So since this is already factored, we set each independent part equal to 0. So clearly -3 and +2 will make the original function equal to 0. So that's for part 1. Part 2 asks us to do a sign chart for f prime and f double prime of x. Alright, so for f prime, what we're going to do is first find the critical numbers. So we take f prime, set it equal to 0. So we have 5x over 3 x minus 2 to the 1/3 equals 0. Alright, so when the numerator is 0, the whole thing equals 0. So since it's 5 times x, we know 0 is one of our roots. And then the other critical numbers is when the denominator equals 0. So since this is factored as well, it's when x minus 2 equals 0. So our other critical number is going to be at 2. Alright, so and now we need to fill in the signs. So what we can do here is just plug in a number in any interval. So let's choose 1. Plug in 1 on top, we get 5, so it's positive. And then 3, 1 minus 2, which is negative, to the 1/3, which is also negative. So overall, the whole thing will be negative. Alright, and then we can use multiplicity to do the rest of the chart. So at 0, so we look at our 0 root, which is right here. Technically, the exponent on that root is 1, so it's odd. So we're going to change signs. And then on this root, it has an odd exponent as well, because when it's a fraction like that, we only look at the numerator. And so this is going to change signs as well. So that is our number line for f prime. Now we can look at f double prime. So just like in the previous one, you just set f double prime equal to 0. Alright, so first we can set the numerator equal to 0. So 10x minus 30 equals 0. 10x equals 30. X equals 3. So we have 3 on our graph. And now we look at the numerator, the denominator. So 9 is never going to be 0. but this is going to be 0, so x minus 2. So once again, we're going to have 2 on our line. So now we can go back and do multiplicity. Well, first we got to test one of the intervals, so let's test this one. Plug in 1.5. Actually, easier to use this one since 0 is on this interval. We can plug in 0. So we get 0 minus 30 is negative over. So no matter what's in here, it's going to be raised to the 4th power. So the bottom is actually always positive. So actually, whatever the sign is on top is the sign. So it's negative there. And now we can go ahead and use multiplicity. So at the root 2, which was x minus 2, the exponent is 4/3. So really, you're only going to look at the numerator. Is it even or odd? It's even. So the sign doesn't change at 2. And then now we go to 3. We look at that root, which was on top. What's the multiplicity on that root? Well, it's just the 1st power. So the sign does change at 3. So this is going to be our line for f double prime of x. Alright, so that's for part 2. Part 3 asks us what are the critical numbers. So if we go back to what f prime of x was, we had 0 and 2 on there with plus, minus, plus. So the critical numbers are all the values on that line. So it's going to be alright, and it says next, f of x has a horizontal tangent where? So horizontal tangent is when the slope is 0. So remember, this came from when the numerator was 0, this came when the denominator was 0. So this is going to be the horizontal tangent. Alright, and then next it says, when does it have a vertical tangent? So vertical tangent is when you have an infinite slope, and infinite is when you divide by 0. So 2 is when we were actually dividing by 0, so we had 0 in the denominator. So we're going to have a vertical or a cusp at 2. Alright, so that's for part 3. Part 4 says, where does it have a relative maximum and where does it have a relative minimum? So you once again go back to f prime of x. Alright, so first it wants the x value. So if the graph is increasing and then it's decreasing, this must be a max. And then over here, it's decreasing and then increasing. That must be a minimum. So first it says relative max. So we have a max at x equals 0, and it wants to know the value at that point. So we would just plug 0 back into the original function. But remember, they gave us f of 0. So you can say f of 0 is approximately 4.8. Now they want to know about the relative min. Alright, so that is when you go from decreasing to increasing, which was at 2. We're going down and then up. Alright, and then they also want to know the value there, so we're going to find f of 2. So you just plug 2 back into f. Well, this is going to become 5. This is going to become 0, so the whole thing becomes 0. So that's where we have a max and a min. Alright. So part 5 asks us, where do we have an inflection point? So let's go back to what f double prime of x was. So remember, an inflection point is when you have a change in concavity. So our only two candidates are 2 and 3. So at 2, we're negative, so concave down, and then we're negative again, we're concave down on the other side. So this is not a point of inflection. But at the point 3, we're negative and then positive, so we change concavity. So we have point of inflection at x equals 3. Alright, and then it asks us for the point, not the x value. So what we have to do is plug this back into here. So we plug in 3, this becomes 3 minus 2, which is 1, so that this is 1, and then this is 3 plus 3 is 6. So we're going to get the point. If they would ask for the x value, it would say 3, but the point is 3 comma 6. Alright, and finally it asks us to graph the function. So we're going to use everything we've done up until here to do that. So let's just remember what points we know are on the graph. We know 0, 4.8 is on the graph. That was given. Alright, from part 1, we knew the x-intercepts were -3 and 2. So we know -3 comma 0 and 2 comma 0 are going to be on the graph. Okay, and then also we know where it's increasing and decreasing from those line charts. So alright, so let's put the 3 points we know on the graph. So 0, 4.8, it's going to be somewhere around here. -3, 0 is right here. 2, 0 is right there. So we know we have to go through those points. And let's recall that the graph was increasing up until 0, and it was concave down up until 0. So it's gotta go through here. It's gotta be increasing the entire time, and it has to be concave down. So we can start from here. We know it's concave down, so it's going like that, and we know it has to decrease the entire time. So it must do something like that. Alright, and then from 0 to 2, it's decreasing, and its concavity is negative as well, so it's still going to keep that negative concavity and decrease down to that point. Okay, and then we know at that point it's increasing after that. Alright, and also we can put the inflection point on there, which was 3 comma 6 from the previous one, which is right here. So we know it has to increase through that point, and it's going to be concave down before that point and concave up after that point. So it's got to do something like this. So that's going to form a cusp, and then this is a point of inflection, so it's concave down, followed by concave up, so it's going to do something like that, and that's going to be your graph of f of x.